So now we are discussing the combination questions. This question is from May 2004, paper 2 time zone 1. But you don't require a calculator for this. This particular question definitely comes in a section B, typical paper 1. And this problem covers functions, derivative as well as integration. So let's start with this first part. Total marks 16. Consider the function f of x is equal to 2 plus 1 upon x minus 1. The diagram below is a sketch of the part of the graph y is equal to f of x. They have given only one part of this part. Copy and complete the sketch of f of x. So let's discuss about this. When we have a function like this is called as a rational function. The denominator, if it becomes 0, the value of the function does not exist. So basically whatever the denominator, if you equate to 0, that becomes x is equal to 1, which is what your vertical asymptote. Vertical asymptote, why? Because x is equal to 1 always cuts the vertical axis. A horizontal axis x, but it is a vertical line. Okay. So here my first part is what you can see here, x is equal to 1, which is basically because of x minus 1 I'm equating to 0. So x minus 1 is equal to 0, so x is equal to 1 is my vertical asymptote. Never draw vertical asymptote with the fixed line or solid line. It always shown with the dotted line, and label this graph. Second one, if whatever the number or constant is there, that is basically called your horizontal asymptote. Horizontal asymptote means what? Y is equal to. Horizontal because it cuts the y-axis. If it cuts the y-axis, you can see here y is equal to 2. Again, I am showing by asymptotes by dotted line and labeling it y is equal to 2. Once we have this, then automatically you always understand that if one of the part is in this part, basically these are new your y-axis and horizontal x-axis. So one part is in this part, the other part always comes in the opposite. So just draw like this. Make sure that your graph will not touch the asymptote horizontally as well as vertically. You don't have to be very specific that which are the points. If they ask, then you need to find out what is your horizontal what is your x-intercept and what is your y-intercept. So right now this is the diagram. Second, write down the x-intercept and y-intercept of the graph. Now they are asking to find out the x-intercept and y-intercept. So what we will do, we will put y is equal to 0 in your equation. F of x is equal to 2 plus 1 upon x minus 1. As it is a paper one, I need to show some steps. So plus 2 take on the other side becomes minus 2, 1 over x minus 1. Now I'm taking this denominator on the other side, making a bracket. So minus 2 times x minus 1 is equal to 1. So minus 2 times x is minus 2x, minus 2 times minus 1 is plus 2. Keeping minus 2 as it is, take 2 on the other side, 1 minus 2 becomes minus 1. So minus 2x is equal to minus 1, so x is equal to minus 1 upon minus 2, which is 1 upon 2, which is 0.5. Never write intercept in terms of this. This is called as a line equation. Intercept is always denoted by a point. So when x is 1 by 2, that is 0.5, y is what? 0. I am labeling this point as a. Y-intercept is very straightforward, x is equal to 0. So I'm again writing that equation, y is equal to 2 plus 1 upon, now I am putting x is equal to 0. 0 minus 1 is minus 1, 1 upon minus 1 is minus 1, 2 minus 1 is 1. So I'm labeling that point as p is 0 comma 1. Vertical asymptote, as we discussed, when denominator is 0, x minus 1 is equal to 0, you got x is equal to 1. Horizontal asymptote, whatever this constant term you are adding in actual reciprocal function, that constant term is basically called as your horizontal asymptote. Y is equal to 2. Don't write only 2, don't write only 1. Asymptotes equations, therefore you have to write down x is equal to 1 and y is equal to 2. This is all about the function. Now we are moving the second part, which is called as a derivative. Now they say find f dash x. F dash x, I am writing f of x is equal to 2 plus 1 over x minus 1. I am rearranging this equation, 2 as it is, 1 as it is, and x minus 1 I am bringing it up, becomes x minus 1 raised to minus 1. I'm still keeping in a bracket. Don't open the bracket. Now let's start taking a derivative. Derivative of 2. 2 is a constant. Derivative of constant is 0. This one as it is. Other than 1, it could be any other term. I know that 1 multiplied by anything is same number or same term, but still I'm keeping for your understanding. Now first I'm taking a bracket derivative. So bracket derivative, that is minus 1 comes down. Bracket will remain as it is. Rest to power is decreased by 1. So minus 1 becomes minus 2. Times, because it's a chain rule. I'm not using a chain rule by showing that. I'm directly using that. Times, you took a derivative of a bracket, but you haven't taken derivative of actual x term. So you have to take a derivative of inside term, x minus 1. 0 as it is. 1 into minus 1 is minus 1. X minus 1 raised to minus 2 is x minus 1 raised to minus 2. Derivative of x is 1. Derivative of 1 is 0. 1 minus 0 is 1. 1 into minus 1 is minus 1. Never keep the rest to power negative, at least in paper 1. So bring it this full power down or full bracket down, it becomes x minus 1 raised to 2. So your expression for derivative of f of x is minus 1 over x minus 1 bracket raised to 2. Second part. There are no maxima or minimum points on the graph of f of x. Use your expression for f dash x to explain why. We know that for maxima minima, the slope at the maximum point or minimum point is 0. Slope means derivative. Derivative means what this. So I need to equate this to 0 and show that I don't get any maxima minima point for this graph. And we already seen that in this graph, I don't see any maxima minima. There is asymptote and they are bending or exponential type. Okay. So if I equate this f dash x is equal to 0, that is minus 1 over x minus 1 raised to 2 is equal to 0. Straightforward, if I'll bring it this down on the other side, it becomes 0 multiplied by that becomes 0. Is minus 1 is equal to 0? No. Therefore, there is no x, no maximum minimum points on the f of x. Next, the region enclosed by the graph of f of x and the x-axis and the lines x is equal to 2 and x is equal to 4 is labeled by capital A. That means this part. We are not taking full graph, only we are taking the upper side of the graph. Find integration of f of x. Integration of f of x, so please write down the same format. If there are two terms, use the brackets properly. Otherwise, you will forget to take the one term integration. So I'm using 2 plus 1 upon x minus 1 because that is my complete f of x. Middle sign is plus, so I'm writing both in a one bracket. Separating this, integration of 2 is 2 times x. Integration of any constant is constant into x. And if you'll see the formula booklet, integration of 1 upon x is ln of modulus of x. It's same thing as like 1 upon x minus 1 is ln of x minus 1. But here the additional part is what? Ax plus b. And the coefficient of x is 1, that is divided by that. Although we know that anything divided by 1 is the same number, but I'm showing this for explanation. And this is not a definite integration, so do not forget to write down plus c. 2 times x is 2x. ln of x minus 1 upon 1 is ln of x minus 1 plus c. That is the answer of first part. Now they say write down an expression that represents the area labeled A. This is still indefinite integration, but when they say area, it becomes a definite integration. And when area, you need to consider the lower limit and upper limit, which is in this case for area A, the lower limit starts at 2 and the upper limit up to 4. So I will write down the same expression, integration of 2 to 4, integration from 2 to 4, again the expression as it is. I don't need to solve this one right now because they just want a write down expression for A. Now third part, they said find the area of A. To find out the area of A, do not solve this because we know the integration of this 2x plus ln of x minus 1. Do not take C because this is a definite integration. When you take integration, do not show the integration sign, show the bracket. Write down the upper limit and lower limit behind the bracket. When you solve for this, you first substitute the x value as upper limit wherever x is there. So 2 times 4 plus ln 4 minus 1 bracket complete minus, when you substitute upper limit and when you substitute lower limit, middle sign is minus. So minus 2 times 2 plus ln of 2 minus 1. 2 times 4 is 8. Ln of 4 minus 1 is ln 3. 2 times 2 is 4. Ln of 2 minus 1 is ln 1. 8 as it is, ln 3 as it is, minus 4 as it is, minus of minus becomes plus ln 1. 8 minus 4 is 4. Ln 3 minus of minus becomes ln 1. Ln 3 into ln 1 is ln of 3 into 1, or you can say ln 1 is 0. Still you will get ln 3. So 4 plus ln 3 is what your final answer. That's it. Thank you.